Hello, good morning. Can you all hear me properly? Hello, kusang bola meram pema.
Good morning, Sering. Goy nga gidi. Goy.
We will start with the webinar. So thank you so much for joining in, and I would like to welcome all to this webinar. Respected our division head, Sonam Sosar, and all the senior employees of CDCL. I would like to welcome again and thank you for joining me today in this webinar. It is my first time organizing such event or such webinar, and I'm a little nervous right now, but I will try to do my best to make you all understand the content as much as possible. And if I make any mistakes or if I face any issues during this webinar today, I would like to request you all to bear with my incompetence and any mistakes that I face during this webinar today. The main purpose of organizing such an event or a webinar is not because that I'm the expert and I know everything. I don't know anything. I don't know everything, but I know one thing, that is that it is very hard and it requires a lot of time and a lot of stamina and a lot of dedication to learn on your own. That's why I would like to share what I've learned over my past hundreds of hours that I spent figuring things out. And I really hope that with today's 30 minutes webinar, I really hope that you all will become a little closer to becoming a BIM practitioner in your AEC career. So with this, thank you Sonam Jamso sir for joining me today, and I'll introduce you to all the viewers, our infrastructure division head, Mr. Sonam Jamso, and his expertise are in building and building structures. So we also have planned of having Gim sir and Kasang sir here today, but unfortunately they couldn't join. So to introduce myself, my name is Sring Tokke, and I graduated from North South University in 2020 August, and by profession I will be a civil engineer. But in the future I wish to be a BIM specialist or a BIM coordinator or a BIM manager. So in case if you wonder what I am doing today, is part of a role and responsibility of a BIM specialist or a BIM coordinator. And if you want to know more about the roles and responsibilities of a BIM specialist or a BIM coordinator, please check the link which my friend Kinga will share in the chat box later on in this presentation, and have a look at it after this presentation. For your information, I have all your emails, and I will send the content of this webinar after the session. So in this session, I will be introducing you to what is BIM and some of the BIM workflows and some of the softwares that we use to achieve BIM. But before going into the content, I would really like to request all of you to take this 2-minute survey, which will help me decide my study goals, and it will also help me develop similar content in the future. So please take out your camera and scan the QR code on the screen, or you can directly go to the link that is shared in the description, and please take this 2-minute survey. Okay, 7 response. Okay, thank you so much for taking the survey presentation today. So the main objective of today's presentation is to make you understand the transitions that are happening in the AEC industry, where it actually started and where it is heading at the present stage. I will also introduce you to basic BIM workflows, and I will introduce to what actually is BIM. BIM actually is building information modeling, and I'll go detail into BIM at the later part of this presentation, and some of the benefits of the BIM. And I will also introduce you to some Autodesk BIM tools and some basic workflows to really get started with BIM. And at the end of this presentation, you will understand the concept of BIM and some of BIM's benefit. And you will also be able to differentiate between a 3D CAD model and a BIM model. And you will also get familiar with some BIM softwares and some of its basic workflows. So to go into the presentation, AEC industry has been undergoing rapid changes, rapid transitions. And if we look at this graph here, people, the designers, architects, engineers, they have been working on hand drawings before 1950. And they were literally drawing all the detailings of the construction drawings and the designs on very huge papers. And later on, in 1970, they have transitioned to CAD, which is also known as computer-aided design. CAD is nothing but just the digitization of the hand drawings. The researchers, they invented the CAD, and then later on all the designers shifted towards CAD, which helped them reduce a lot of paperwork and which developed an opportunity to go towards more complex designs where you name it as a parametric design. When we say parametric design, it deals with complex designs, complex structures, like you can see in this photo here, where the model requires more mathematical equations and there are more parameters, more variables, dependent and independent variables in the equations. And later on, the designers, the architects and the engineers, they come to know that to do more complex designs, when the project is becoming larger in scale, the 2D and the 3D design was not just enough. They needed more information. They needed more CAD softwares which can handle complex designs. So they transitioned towards the algorithmic modeling, where the more equations and more mathematical parameters come into play into designing the models. So that's what we call parametric design. And later on, more information has been added to the models, where it gave rise to the building information modeling later in the year 2005, 2007 onwards. And in this workflow, the interoperability was the key function. Okay, thank you for joining me today. So in all this process, interoperability was the key process, where the softwares are functioning interdependently, where you can export the model from one software to another, and you can save the big data drop. You can directly use the data from one software into another software. That is what we call interoperability. And people also worked on photogrammetry, where they can design the present scenario just by clicking photos and making videos of the present scenes, and then they put it into the software, and then the 3D drawing was automatically generated from that software. And that was also not enough, and they were also researching more into AI BIM, where the artificial intelligence were also collaborated with building information modeling and the machine learning. All these AIs were collaborated into BIM, where the models were generated based on the information that you feed into the model. So people also started doing robotic constructions. If you see here, people also started using drones, cranes, or robotic. Basically, the AEC industry is trying to cope up with the manufacturing factories, where you see the motor cars were manufactured part by part, and then they are fixed together, and finally the output is being generated. Maybe in the future we can expect similar things in our industry as well. The part of the buildings may not be the same, but researchers are working on it. They can model the parts of the building and then finally come together, like 3D printing, and then the building is there on the real field. And presently, people are working on the Internet of Things, where everything is being connected with the help of internet. All the devices, all the gadgets inside your home, maybe all the components of your home in the future will also be connected to internet, and they can function with very minimal effort from the human beings. The best example of Internet of Things that I've showed you in the previous video is like a smart home. When the alarm in the morning goes on, it will automatically triggers the coffee machine. It will automatically turn on the switch for your water boiler or the water geyser in your washroom. So things are becoming more and more interesting and more dangerous if you take it in a negative way. Thank you for joining me. So that is basically how the AC industry has been transitioning over the last 20 years. And BIM is one of the process, one of the stages that into that transitioning period. And if we look into BIM, BIM requires a lot of information. Thank you. BIM requires a lot of information to make it possible, make you possible understand all the clashes or all the issues before being constructed on the real ground. So one thing that you need to understand is the dimensions in the BIM, the dimensions in our AC industry. Presently, we have 7 dimensions. I hope all of you are aware of 3D, just a 3D modeling, the X, Y, and Z coordinates. And if you add the time schedules, to the 3D model, then it becomes the 4D, 4-dimension. And if you add the cost scheduling to that 4-dimension, it will become 5-dimension. And there are 6 and 7-dimension. Like 6-dimension is when you add all the information about the analysis. If you do analysis of the energy, the HVAC system, the amount of light entering into your room, or the analysis of the wind and the flood analysis. If you include all the analysis, basically how well your project is sustaining into its environment, that is the 6th dimension of the BIM. And the 7th dimension is basically to do with the maintenance purposes, the warranty card that comes with your building component, like how often you should change, what are the life cycle of your building component. This adds up to your 7th dimension. And if you want to know more about the dimensions, I have the resource in the resource folder, which I will share with you at the end of this session. So what is BIM? So most of the frequently asked questions are like, is BIM what we call the 3D modeling? Is that what BIM is? Or is BIM itself is a software that has all the functionality in that one software that you can use it and have the output? Thank you. Or is Revit BIM, or is BIM Revit? And another frequently asked question is like, does BIM involves only the buildings? Does BIM only deals with buildings? So with these frequently asked questions, I'll try to explain you the definition of BIM. According to the 2014 Wikipedia, BIM is a process of generating and managing building data during its life cycle. So you need to be careful here, because BIM is not a software, or it is not just 3D modeling. BIM is a process. It is a process of generating and managing the information that you have about the project, or that you have about the model. So basically, you are managing the information about that project during its life cycle. It is not just before constructing. It is not during the construction period. It is throughout its life cycle. So according to 2017, BIM is a process involving the generation and management of digital representation of physical and functional characteristics of places. So it is not just the physical, it is also to do with the functional characteristics of the places, not just buildings. It can be utilized for any type of civil works, or any type of infrastructure designs or projects. So basically, BIM is a process which encompasses building geometry, special relationship, how well your building or how well your project is functioning according to the environment, and some of the geographic information about your building, or geographical information about your project, and what are the quantities and the schedules of your projects. So the quantities explains you the information, how much windows, or how many windows, how many doors, or how many columns, how many what is the length, everything that is to do with the information. It is a process in the BIM. So the most important thing when you talk about BIM is the function interoperability. So BIM is not just one software. BIM is combination of many software where you can use various software to its own purposes. If you look into the structural analysis software, it is the best software for doing the structural analysis. But if you look into the 3D modeling, it does not do the structural analysis, but it does the 3D modeling. So BIM is basically a combination of various software where the files can be extracted and exchanged among the software or among the designers, and finally achieve the product. Okay, thank you, sir. So when you look into the BIM, it is very important for you to understand the difference between the CAD model and a BIM model. So if you look into this, two models, one is a CAD model and another one is a BIM model. CAD model is just the representation or just the geometric shape and form of the structure and nothing more. But if you look into the BIM model is also the representation. It is also representing the geometric form and shape of the structure, but it also has the information about this structure. It is not just the component, not just the representation of the component, but if you look at the two walls here, one is the CAD model and another one is BIM model. The BIM model has the information about the wall. 3D CAD model is just the representation of the wall, but BIM model has the information like the length of the wall, how high is the wall, what are the different components that make up this wall, like the core or the mortar or the paint. So what are the different types of the layers which makes up this wall? So it is basically having all the information necessary to construct this wall. So that is what a BIM model is. So a BIM model is more than a CAD model, although a BIM model usually looks very similar to a 3D CAD model. And the key difference here is the information that is attached with the model. So I hope you understand the difference between the CAD model and a BIM model. So some different terminologies that are used for BIM are like building information management. People also say it is the management of the information, which is of course very true. And people also use the building knowledge management. It is not just the information that you have about the project. You need a vast background, or you need a lot of knowledge just to provide a handful of information. So that's why it is also called as a building knowledge management. So it is all the information that we have about the project is for the construction of the project. That's why it is also termed as construction information modeling. And it is not just limited to buildings. It can be used anywhere in any type of infra works project or any civil works. That's why it is called as civil works information modeling. But the baseline is, it is just the more common term used for BIM is the building information modeling. So why do we need BIM? So we need BIM. We really need to practice BIM because of the benefits of the BIM. So the benefits of the BIM, it will let you know how it will look like at the end of the construction, how much would it cost, how long it will take. The BIM has all the benefits. So we need BIM because of the present challenges. The projects are becoming larger and becoming more complicated. Projects are coming into execution, and we need faster and better quality and safer delivery of the project. We need to manage the full life cycle of the project, and BIM helps in especially the operation and maintenance of the project. So right now what we do is we are just caring about the pre-construction and during the construction. Once the building is constructed and handed over, you of course it is true that you are not responsible for it, but if it is a BIM model, then the owner will thereafter take the responsibility to do the maintenance of the component, which will minimize the cost of the project, both for both the contractor or the designer or the stakeholder or the owners. So BIM is a new ability to manage the information, to do the digital simulation of the real world in a cyberspace before constructing, before operating the project in the real field, and it also helps a better collaboration between the designers. So some of the benefits of BIM are like it will automatically generate the two-dimension detailings. The thing that you need to do is you have to model the BIM model just like you are constructing the project on the real field. So once you are done with modeling the BIM model, you can take section from anywhere you want, and the 2D detailings will be automatically generated. And the best thing is that if you make any changes, if there comes any changes in the design later on, and if you change any if you make any update to the BIM model, it will be automatically shown and reflected in all the views, all the sheets, all the layouts in your 2D detailings. So BIM is not just limited to buildings. It can be used anywhere in the InfraWorks project or civil work project. Like you can also use it in the bridges, BIM model for bridges. So unluckily we don't have our bridge expert here today, so maybe in the future we'll make similar content on the bridge project about the BIM models. We can also use the BIM models for the power line cables, power projects, where you can do the underground design. You can use the analysis function to analyze the power in the transmission lines. The best thing is that it has the power to integrate multiple systems. All the construction firms, all the top design firms, they use this BIM. They just model the architectural model and then distribute it among the multidisciplinary engineers, like the structural engineer, the MEP engineer, the electrical engineer. All the engineers are working on the same model at the same time on their own, on their respective fields. So once they are done with the modeling, they are going to put it together in the master file, the master model, and then they are detecting the clashes, whether the MEP members are clashing with the structural walls or MEP members are clashing with another MEP members. The clashes can be detected beforehand, and it will save you a lot of time and a lot of resources during the execution of the project. BIM also coordinates among the stakeholders and the designers. Like if whether you want to change the design or keep the same design, you can discuss with the stakeholders in the platform, and you can incorporate any changes. You can show them the design virtually before constructing it on the real ground. So the last benefit of BIM is BIM basically acts as a platform where you can rehearse your project before executing it on the real ground. Like how well your building is fitting in your surrounding, in that surrounding, or how well your building is reacting towards all the environmental changes. So basically you can rehearse it, you can analyze your building before constructing it on the real ground. Presently we are using virtual design and construction, which is also called as VDC. But we are not bothering much about the information about this building. So we need to really consider the information that are required for the construction of the building. So these are some of the benefits of the BIM. And in order to achieve the full functionality of the BIM, we need the right tools. We need the essential tools that we need to achieve the full functionality of this BIM process. So we have Today I have here 4 essential tools that we need for a successful BIM project. But there, when you go advanced in the BIM, like there are lots of essential tools that we have, but maybe we will look at it in the future. But today we have 4 essential tools. That is, first we have a BIM management platform, where this platform can manage all your files, manage all your plans, all your schedules, right from the inception of the project till the handing and taking of the project. The second tool that we have is a common data environment, where you can share all the data with everyone you want. From that one platform, you can share, you can get access to the data with different level of accessibility to the data. The third tool that we need is the authoring tool that governs all the rest of the tools, because if you are an architect, you need a very powerful tool for modeling, 3D modeling. If you are a structural engineer, you need a powerful tool, very user-friendly tool, where you can save a lot of time in designing complex structures. You need a design and analysis tool for your structures. If you are, I'm really sorry that we don't have any softwares included here for electricals and water supply engineers, but Revit is a very good tool that you can use for electrical and MEP purposes. So the fourth tool that we have is a clash detection software. It will detect all the clashes beforehand, and it will help you solve any issues that if you didn't do the clash detection, you will face the same problem in the real world, and it will cost you a lot in the real field. So the BIM management platform, the best software we have for this platform is the Plannerly, and you can have a detailed review of this software. If you go to the link on YouTube, you will have a very clear idea what this software is capable of. But if I try to explain it in short, Plannerly, this BIM management platform allows you to document all the informations necessary, required for the purpose of one project. You can have multiple projects on this platform, and you can put information that are required for each and every project, like the contract, starting from the contract to scheduling, planning, and even tracking of the progress, and then verifying the status, verifying the designs among the stakeholders or among the designers. It offers all the features that you need to digitize Bhutan or any other country. Right now we are focused on paperwork and as well as on the digital. But with this software, I'm really optimistic that it will help. It will have all the features that you need, so that you can skip paperwork and do everything on the digital. And the next tool, the common data environment, the best tool for this is the Autodesk BIM Collaborative Pro. It was formerly called BIM 360. So right now I'm just familiarizing you with all the software names and the basic functionality of these softwares. So this software allows you to collaborate on just this software is a cloud-based platform where you can share all the data, where you can store all the data on this platform, and anyone from anywhere can get access to this data. And this will help you speed up the model review. Like, you don't have to wait, you don't have to go, or you don't have to wait for your model to be reviewed. You can just submit the drawings on this platform, and then the chief planner or the chief designer will approve it, or it will figure out any problems, any type of problems that you have in your design. The chief designer will approve it and will comment on your designs through this platform. The next is the authoring tool. I didn't include SketchUp here because there is a very big data drop in SketchUp, and if you are a SketchUp user, maybe you can expect a better feature from the researchers or the developers. Right now, SketchUp is not compatible with any of these software. Of course, you can save the file format in AutoCAD and then use it in the Revit, but there is a very big data drop. you have to model all the structures from the scratch, because things are not very working very smoothly. I have tried it, but it is not working well. So you need 3 different tools for modeling, drafting, and design and analysis software. So the last one is the clash detecting software. So the clash detecting software, it detects any type of clashes. When we say clashes, there are basically 3 type of clashes. One is hard clashes, the another one is soft or buffer clashes, and the third one is construction clashes. Hard clashes, it means that, for example, your mechanical or the plumbing duct is directly clashing with the structural columns or the structural beams. So you need to avoid such clashes. This software will help you detect any clashes, and it will help you change or modify beforehand. The buffer clashes means the members are not directly clashing, but when you try to install the members, or when you are doing maintenance for the members, it is clashing with other members. So that is soft clashes. And the construction clashes, best example would be like you have a small room and you need to pick a very big generator inside this room. So you cannot put the generator after constructing the roof for that building or roof of that room. So you need to plan, you need to simulate how you are going to avoid the clashes. So this software will basically help you analyze all the clashes, all the possible clashes that your model will have, and it will also help you do the 4D simulation. It will also help you do the animation. Like when you are going to construct the project on the real field, how are you going to do it? When are you going to call in the concreting trucks, or when are you going to use the cranes if you are dealing with big structures? So this will help you make small simple animations on how are you going to proceed with the workflow, and you can share it with your team, you can discuss with your stakeholders, you can discuss with all the surrounding stakeholders which may or may not be affected because of your project. So it is a very helpful tool. If you want to know more about this tool, please go to the link and check it out yourself, and I'll also share the resources after this session. So having said this, where are we now? Are we still in CAD, or are we already into BIM? So I think from the previous survey, I believe that we are still very much into the CAD. And if you say that you are on Earth, then we are in trouble, because the outside world, all the designers, all the researchers, they are also on Earth, and they are far advanced than us. So we really need to take that one big step, because the digital transformation is happening so fast, and we really need to take the big step, because if it is not us, then who is going to do it, who is going to take the step? And if it is not now, then when are we going to do it? So with this is me, and please you can get access to the resources from my website, and you can also add me on your social medias. So that's it for today, and thank you so much for joining. I would like to acknowledge CDCL for giving me the platform and resources to groom. I'm learning a lot here, and my special thanks to all the division heads. Unfortunately, they are not here today, for supporting me and for encouraging me to share my knowledge. And I would like to thank all the resources, content. I would also like to thank the Construction Division Board for giving me 2 months Coursera license. And I would also like to thank the Coursera courses like BIM Fundamentals and BIM Application for Engineers for providing me with useful resources. And please make sure to check out the YouTube channel BIM Integrated BIM if you want to know more about BIM. And if you want to keep on track, if you want to know what are happening in the field of AEC industry, please check out the Autodesk University website or the YouTube channel. They are very informative. So thank you. I hope you like this content, and please, I would like to have your honest feedback, which will help me correct myself, improve in the future, and develop similar content in the future. and please, you can access the resource in this resource folder, or I'll share it with you all via email. So thank you so much, and if you have anything to comment on my presentation today, I'm very open, and I would really like your feedbacks and comments.